Hello, everyone, and welcome to the webinar on data protection with NetApp Snapshot Copies. Thanks for joining us today. This is your host, Dan Murphy. You may have read my short bio when you signed up for the webinar. If you didn't, I'd like to take this opportunity to introduce myself. I've been working in the IT training industry for over 30 years. I specialize in helping IT directors, CTOs, and managers address their IT training needs with a focus on state and local government and education. I could go on about myself, but I want to move quickly on to the real star of the show, the presenter of this webinar, Alicia Townsend. Alicia is a technical trainer and consultant with more than 25 years of experience in the industry. She's a Microsoft and NetApp training certified trainer and has helped thousands of students upskill themselves in a number of technologies. I'm sure you read about her before you registered, and I am sure many of you are here because you read about her. She's one of the most experienced instructors on our team and has put a lot of work into the webinar. So Alicia, tell us why you chose this topic.
Thanks, Dan. Well, I chose the topic because it's actually one of my favorites. Data protection obviously is important in this world. And so it's a good refresher. I think it's one of the core concepts that NetApp users need to know about. So it's a big part of what I stress in my training. And it's a good topic for anybody who's really new to NetApp. So that's why I kind of chose this topic.
Okay, I want to say welcome to those who are just now joining us. Welcome to the webinar, Data Protection with NetApp Snapshot Copies. We are here with Alicia Townsend, and we are just about to start with the presentation. So let's get started with the webinar. Over to you, Alicia.
Excellent. Thank you, sir. All right. So before I get started with the session, I want to let everyone know that you can send your questions in throughout the session. We'll address some of the questions during the session and then have some time at the end, hopefully. So I'll try to make sure that we answer all the questions as they come in. Of course, if it gets a little too overwhelming, then you can always drop Dan an email. So if we don't get time to get to your question, drop him an email at dan.murphy@quickstart.com or join us at Expert Connect at expertconnect.quickstart.com. So I believe Dan already put the link in the chat window. So make sure you can get it from there. All right. So now I am going to start my presentation. So let me share my screen here, and we are going to go over data protection with NetApp Snapshot Copies here. So first we're going to talk about local snapshot copies. Again, one of the core features of NetApp storage systems are these snapshot copies, which they call copies, but I always like to clarify, it's not really copying the data. And so that's one of the core things that I want to make sure that you get out of this presentation, that you really understand I'm not copying the data, I'm actually just copying the pointers to the data. But this basic process of creating the snapshots is key for a lot of other features that we get out of NetApp. So cloning capabilities, my ability to archive content, my ability to replicate my content, so SnapVaulting and SnapMirror, all of those are dependent upon these snapshot copies. So we're going to talk about the basic process. I'll give you a few little hints as to how it might be different if you're setting it up for NAS content versus SAN content. And then we will look at how these snapshot copies are utilized in the flex cloning process, SnapVaulting, as well as snap mirroring here. So first, local snapshot copies. So one thing that I want to, again, get clear here is when I create a snapshot, so the idea is I've got a whole bunch of data blocks here, right? Belong to my particular file that I'm working with. And I've got pointers to those data blocks. So that's what we're seeing over here with the inodes. And my data blocks we're representing as A, B, C over here. Okay, blocks on disk. And the idea is when I create the snapshot, I'm not copying the data blocks, I'm just copying the pointers. And thus we see the inodes pointing to the same data blocks. So the only thing that's being copied when I create the snapshot are the pointers to those files. Okay, thus the copy part of snapshot copy. The other thing that's happening is the data blocks become frozen. They cannot be deleted and they cannot be changed. So basically I've got, read write access if I'm connecting from the active file system over there. And if I connect via a snapshot, which I can do, like through the file system, I can actually browse to these snapshots. They're hidden folders on the file system, but I can browse to them. But I get read-only access if I'm looking at a snapshot. So I'll see all the files as they were at that point in time, but I won't be able to modify them. So life goes on after I create the snapshot. So say I took the snapshot at 10 a.m. That's my production instance rights. We're constantly having new rights come in, and maybe one of those requests needs to change a particular data block. So what will happen is, so say it needed to change little C over here. It can't change C, that particular data block on the file system, because the snapshot is still pointing to it. So the only thing that it can do is create a new data block with the new version of whatever that information is. So at this point in time, the production instance or active file system, will no longer be pointing to that C block. Okay. So what is in the C block is really at this point only owned by the snapshot. So it is a data block, or obviously if this is multiple files or multiple data blocks that got changed, okay, those are data blocks that only the snapshot is pointing to. So at this point in time, actually, this is when the snapshot starts consuming space. So what do I mean by that? Well, I mean, when I initially created the snapshot, all it was copies of the pointers. So the original amount of space when the snapshot was created is incredibly negligible, maybe a few K or so. Okay, depending upon how many pointers, maybe a little bit more than that, but again, quite negligible compared to, gigabytes, terabytes of storage or so that we're dealing with. So as we, however, delete and or change data according to that active file system that we can modify, the active file system is no longer pointing to particular data blocks, and my snapshot size will increase over time. So snapshot size increase is relative to the delta, the changes in the data over time. So then we sort of go along our merry little way, and it's now like 11 a.m. and maybe we create another snapshot. And this new snapshot will point to, A and B here, but again, it's a copy of what the active file system was pointing to at 11 a.m., which would include our little friend C prime over here. Thus, this guy is pointing to A, B, and C prime. And again, for some reason, he's not there, but that little pointer to C is no longer there, of course, from before. So idea is, again, this snapshot at this point in time, just a few K in size. It's just the pointers. But as the active file system, maybe delete some files, changes some files, over here. Now this snapshot is increasing over time. And I stress this because quite often what we miss when we first start using NetApp storage system is this phenomena where I've got, say, this rectangle here, beautifully written, represents my volume. And maybe I have snapshot reserve set up. So I've got, maybe, 10 gig over here. that's used just for snapshots to consume space. So as these snapshots increase in size, right, as the data changes or is deleted, we will see this space starting to be consumed. But of course, we have files that we're storing on this. So this is my usable space within the volume. And these are all my nice little files that my users are seeing and working with. So we as like storage administrators, or my users even, want to clear up some space. And so they decide, well, you know, I'm going to clear out this volume by deleting a whole bunch of files. Boop. So they have, oh, that turned out even worse than before. They have the snapshots that we're consuming here, and they deleted all the files that were consuming that space before. But they don't seem to get much space back. Well, what happened was, of course, there were snapshots that were pointing to those data blocks. So when they deleted all those files, the snapshots grew. So they ate up the space within the snapshot reserve. And because it was more than, say, 10 gig that I had for the snapshot reserve, they started eating into that usable space within the volume itself. So this is something, again, if we don't really understand how snapshots work, becomes a little disconcerting when we're first working with the NetApp system. So what do I do to really free up that space? I've got to delete snapshots. If I delete snapshots, then I would be clearing out all that space. Okay, so just to make sure we understand the basic process. Of course, creating these guys are pretty easy to create. You know, I can create it through the command line, I can create it through the GUI. This is a screenshot of, you know, our GUI tool, System Manager. Okay. And again, when we are creating snapshots, how long we retain those snapshots is important in our overall design. If our data doesn't change all that much, like it's more used for like analytical purposes, probably don't need to retain the snapshots for very long, nor do I have to update the snapshots all that often. Okay. Depending upon how much acceptable data loss we can go for, that will affect like how often we're creating those snapshots, right? If I'm creating a snapshot every hour, I could lose up to an hour's worth of content. So all my snapshot overall design obviously is important for determining based upon, you know, recovery time objective, how long is it going to take me to restore things? The files that are in those snapshots can almost immediately be restored using things like Snap Restore, or users can even restore them on their own, just copying the files over from those hidden snapshot folders or using Windows previous versions features. So that recovery time objective is based upon whether I want local snapshots, how far back do I want those local snapshots to go? And then I might have needs that I need, you know, backups going back, you know, 7 years or something along those lines. Or I need backups that are, you know, a few months old. So when I need to go back further in time, usually I'm looking into solutions like SnapVault that we'll talk about a little bit later, or I am dumping down to tape. Okay. And again, recovery point objective here will be determined based upon how often we want to create the snapshots. I ultimately do have a limitation of how many snapshots I can keep. Currently on tap 9.3, it's 255. That actually increases quite a bit. 9.4, which is coming out shortly. Okay. And again, I can somewhat protect myself from those snapshots eating into my usable space by utilizing that snapshot reserve. Now we do have snapshot reserve at both the aggregate and the volume level. Here, usually we're just setting it at the volume level. It's now actually zeroed out at the aggregate level. Okay. And not only can we protect ourselves from like be running out of space because the snapshots by setting snapshot reserve, but we also have features like auto delete, which will automatically start deleting snapshots when I have like 20% free space at the volume level, and it'll delete the older snapshots first, kind of thing. Or enable auto grow. So we'll increase the size of the volume when I have about 20% free. And you can control like which one of those kicks in first and different threshold values as necessary. Okay. The snapshots themselves, when we're viewing them, in fact, we can view them over here in my environment. Drag this guy over for y'all. And if I go to my file system here, and for example, here's the hidden snapshot folder. And if I navigate into here, I can see these are all these snapshots that have been created for this particular volume. And the naming convention is quite handy. It's got a little label there, tells me which schedule it was created on. Or this one was created because I had created a flex clone, which I'll talk about later. Or these are created as part of the SnapMirror replication process. And then we have a timestamp information in there, which of course is very, very handy. Previously in the earlier versions of the NetApp operating system, they would kind of rename each one of the snapshots, and the newest one was like always ended in 0 kind of thing. So that wasn't the best naming convention. The newer naming convention, much, much easier to understand. All right. One of the things that I wanted to make clear though is when I'm creating all those snapshots on the local system, like doing snapshot create from the command line or going through System Manager to create the snapshot, that is really relevant to the world of NAS. Okay. So in NAS, NFS or CIFS, or we call it SMB as well, those NAS protocols, the NetApp system, it's waffle, right? Anywhere file layout, file system is keeping track of where all those files are. It's in charge of making sure all the writes are quiesced down to the disk before it creates the snapshot, so all the files are consistent. So it's fine if I create snapshots on a regular basis using my snapshot policies that can apply to my volumes that determine like how often those snapshots are created, like every hour or once a day, a combination thereof. Okay. It's fine for all of that to be managed, or you manually create a snapshot on the NetApp systems, all be managed from the NetApp point of view. Okay. The only thing to be careful about is what I warned you about earlier. Deleting files does not necessarily give you more space, because again, once I start deleting files from like the client's point of view, those snapshots will increase in size and they can start eating into my usable space. Again, by default, I get protection from that happening because I have a snapshot reserve, which by default is at 5% of what the volume size is. So if I create a volume for simple numbers sake that is 100 gig in size, I will get 95 gig of usable space, and 5 gig of that will be set aside just for those snapshots to consume the space out of. So NAS local snapshots can take advantage of snapshot policies, i.e. have their snapshots created automatically over on the storage end. Okay. NAS volumes by default have a snapshot reserve. And again, I am warning you, when you're deleting files thinking you're freeing up space, if there are snapshots on those volumes, you might not actually be freeing up any space. So you might have to actually delete some snapshots. SAN, however, is very different. In the world of SAN, the host, like the Windows server here that, running SQL or something like that, that's actually connecting to a LUN that is within the volume that I have snapshotted. This Windows OS, he's in charge of what's inside that LUN. He's in charge of making sure that writes quiesce or flushed to the storage end and then thus flushed down to the LUN itself, eventually because of consistency points. So in the world of SAN, I cannot use snapshot policies. Okay, I can't apply the snapshot policies to those volumes because I don't want my snapshots to simply be created over on the NetApp side. I need some sort of application or agent to run on that host. And there are various options in the NetApp world. I put a few of them there. Snap Creator is actually another one. Of course, they all start with the word snap. Okay. So SnapDrive talks to the operating system, Snap Manager products talk to applications, and then they talk to SnapDrive, and Snap Protect and Snap Creator both have agents that kind of do the same thing. And all of them are about making sure everybody knows, okay, we're about to back things up. So y'all need to flush or quiesce all your writes over to that line. And then once we have done that from the host point of view, then these products also will talk to the storage systems and say, okay, now you can go create a snapshot. Thus ensuring that I get a consistent backup of my content. So it is really important in the SAN world that we are not like manually creating snapshots through System Manager or the command line, nor have we applied any of those snapshot policies to the volumes that contain those LUNs. What we really want to do is manage all of that from some component that is running over on the host end. And the SAN volumes, if I create them through the GUI, they actually don't have a snapshot reserve applied to them, but they do have the auto grow and auto delete features automatically enabled for them. And that's how they sort of protect their space, making sure that they always have enough space and that they don't run out of usable space within the volume, thus for the LUN, because of snapshots, because obviously that can take my applications offline. My SQL server, my ESXi servers, VMFS data stores going offline would be really bad. My users running out of space for their files, usually not quite as bad, but of course we can store application data on the NFS volumes as well. So still need to be careful. All right, so again, I always want to stress when we're talking about snapshots, depending upon what's in those volumes, if it's files, manage all the snapshots from the storage point of view. If it's LUNs, I really want to make sure I've got some sort of agent or NetApp software, something that is coordinating the creation of those snapshots with the application and or the operating system of the host. All right, so now we're going to go into just kind of looking at some of these features that are dependent upon snapshots. And one of my favorite is flex clones. Why do I like flex clones? Because it creates instant clones. Woohoo! Why is that cool? Well, that's so cool. Like I work with databases all the time. I love data. And that's in fact how I got into NetApp storage, because we need central storage for my lovely SQL databases. And thus we go towards NetApp storage. Yay! Okay. So in my world, often I need to create a copy of an entire database. And of course, these databases can be huge nowadays. So my request goes into, because I need to test against this thing, right? I need to test against it, or I need to develop against it. So I need a copy of what's in production. So normally I would have to like put in a request to those who are in charge of production database, and I need to wait for them to go create a backup. And depending upon the size of that database, it can take a long time to create the backup, as well as it's going to consume a significant amount of space for the backup. And then they need to make sure they have some space to restore it to. And then I need to wait for them to restore it. And depending upon, again, size, availability, and how well I'm getting along with the guys who are in charge of that database, i.e. how quickly they're doing all this, it can take quite some time for me to get my information. And what I want is to make sure that I can get it a little bit faster. So flex clones give me that capability. Flex clones enable me to get that copy nearly instantaneously. And the way they do it is by using snapshots. So remember we talked about the fact that like the active file system is read-writable when I connect to it. So that's what we're calling the parent volume here, right? That's where my production content is. And if I were to mount a snapshot, like browse to those snapshots that I just showed you in the file system, it's read-only. So I can't make any changes through the snapshot. But a flex clone is me basically taking that snapshot and creating yet another copy of the pointers. So just like the snapshots created very quickly because I'm not having to copy any data, I'm simply copying over pointers. And so by copying the pointers, I get my clone. And my clone is read-writable here. Okay, so my clone, highly beneficial, obviously, because now I can not only see this guy, so now I can mount up this volume, and if it has a LUN, then I'll connect to that LUN, and I can attach the data files to my instance of SQL, and I can go on my merry little way. Now, as long as it is a clone, it is in fact sharing data blocks with the parent volume. If this is something that I need to keep for a long period of time, then I might actually split it. Thus give it its own copy of those data blocks. And that split process can take a little bit longer, right? Depending upon how many data blocks we're talking about. And the split process will cause the clone to consume more space. Again, depending upon how many data blocks we're talking about. But the split process can go on in the background. So I, in my little dev world, am totally fine. Don't have to worry about my performance or anything along those lines. I can go along my little merry way. It's just in the background, it's splitting up my data blocks. So again, create the clone. I immediately have something that I can connect to and start using through that clone. And then depending upon the future needs, we can split it at any time. And thus, they will become totally separate volumes that are managed separately, and I won't really have to worry about it. So independent volumes can be created again once I have created the clone and then split them. So creation of these guys, again, this is a license feature, by the way, so do you need a license for it? But once I license, I can easily create it both through the GUI as well as through the command line. And of course, if I want to come along and split it, then also I can do that through the GUI as well as the command line. And look at their little warning here, right? Might take a few minutes. Again, basically depending upon the size of the volumes themselves. Okay. Now, another feature is my friend here, SnapMirror. So SnapMirror is all about replication. SnapMirror is usually what we talk about when we need disaster recovery type solution. The ability to have a copy of my data someplace else in case, the tsunami comes and wipes out my data center. I live in California. I don't know why every time I talk about this, I bring up tsunamis. I should bring up earthquakes, but I consider earthquakes land surfing. Not as afraid of them, apparently. So tsunamis seem much more exciting to come and wipe away a data center. Anyway, so when we are talking disaster recovery, like I need a copy of my content, on the other side of the mountains, or even, I'm in San Francisco here and I need a copy in Chicago because that's where our DR site is. Then I am going to start bringing up SnapMirror in the conversation. So the idea with the SnapMirror architecture is I will have a source volume over here. And that source volume, of course, is like my active file system, right? Okay, so this is where I'm connecting to my ESXi servers, my databases or whatever, where their files are being stored. And I can either set up SnapMirror within the same cluster, and we call that intra-cluster SnapMirror relationship. So we just have another SVM within the same cluster, and we're replicating over to it. Or I can have it replicate between two clusters. So I would use the intra-cluster SnapMirror relationship for scenarios like I want to make sure that if my HA pair goes down, that I've got a copy of the volumes on some other nodes within my cluster. Or B, I might set it up because I have this other SVM and I want a copy of the data, maybe just for read-only purposes, like for analysis type purposes. So I'm going to SnapMirror over to this separate SVM, and then those applications can connect to that destination. Okay, so that's intra-cluster snap mirroring. The inter-cluster snap mirroring, that's the true DR. That's where I've got my cluster in San Francisco, and I've got another cluster over in Chicago or whatever, and we're going to replicate over to that cluster such that if the tsunami comes and wipes out my primary data center, I can fail over to the SVM that is located in that other cluster that has the copy of my content. Okay. And nowadays we can actually SVM an entire, SnapMirror an entire SVM. So all the volumes within it can be snap mirrored over to that destination, along with a lot of those configuration settings. So it can make that failover process go that much smoother. Of course, I do need to worry about how to reconnect all my clients and such, but at least all the data is there. Okay. So thus, also another use for having that content over in the SnapMirror destination is to have the ability to create clones and or dump to tape over in that other location. So that's kind of nice too. So we talked about my flex clones for dev test purposes. Well, maybe the production guys don't want me to consume any of their resources over in the primary data center. So they'd really rather prefer that I connect to volumes that exist in the DR site. So they can replicate the content over there, and then we can create flex clones off of any of the snapshots that exist on that SnapMirror destination volume. Thus, I, as dev test type person, can connect to those volumes, and I'm not competing for any of the IOPS over in the production cluster. Okay. And or I could dump to tape. So again, dumping to tape, I'm going to be reading a lot of data, competing for resources. Okay. And thus, again, I can offload that work onto that SnapMirror destination. Okay. So very, very nice, clean technology. And again, all of this based upon snapshots. How is it based upon snapshots? Well, the idea is I'm going to create an initial snapshot. I've lost my mouse. There he is. I'm going to create an initial snapshot on my source. And whether we're talking the intra-cluster or inter-cluster, when I initialize this SnapMirror relationship, basically I'm copying all the data that's in this initial snapshot over to the destination. So this is like snapshot 1, and I'm copying snapshot 1 over to my destination. And that's what we call the initial baseline transfer. And when we're configuring the SnapMirror, we're typically configuring some sort of schedule that we want this content to replicate over to the destination. So say I'm going to do it like every hour. So the idea is when I am ready to do the new replication, I'm going to create a new snapshot copy over on the source here, and I'm going to compare the new snapshot copy to the previous one, and that's going to give me a delta. What's changed? And so all that gets transferred over are just those data blocks that basically the two did not have in common. What's changed? And now I can create a new snapshot over here. And in fact, I don't really need the previous snapshot anymore. So I don't need snap 1 anymore, because as we keep going forward in time, in the next hour, we're going to go create a new snapshot. And then from that new snapshot, I'm going to compare to the old one, get my delta, and again, transfer the changeover. And now I have the new one over there. Okay. And in SnapMirror, it's an exact replica. So in fact, what it's, the initial baseline transfer is copying all snapshots, as well as, whatever I snapshotted when I did the initial baseline transfer over to that destination. Okay. And so we'll always have like the exact same number of snapshots on both sides, which is why the icon for SnapMirror is always like, this looks exactly like that. Okay. Now, when we talk about SnapMirror relationships, just a couple of points here to kind of fine tune it. There are a couple of different ones. We can use the ones that I was talking about for data protection purposes. So we're setting that up like between two SVMs, two volumes, or snap mirroring entire SVMs from one place to another. Or we can use what is called SnapVault, which we're going to look at in the next module. Because one of the things to understand about SnapMirror, or SnapVault actually, is it's actually using the SnapMirror engine under the hood. And this has been true since their incarnation. It wasn't quite as obvious until they actually went to cluster data on tap. So now to create a SnapVault relationship, I'm actually using the SnapMirror command. I'm just specifying that it is of type XDP, so extended data protection. But there's a third type of SnapMirror relationship, and that's called load sharing SnapMirror. And it's for a very specific use case. A load sharing SnapMirror occurs within the same SVM and creates replicas of that particular volume. And they're all read-only copies of the volume. And my clients automatically get directed to that read-only copy. So they're used primarily for the root volume of the SVM, because it's not meant to contain any files. It's only 20 meg in size. In fact, I had a student earlier this week who put some files into it by mistake, and that actually messed up their ability to mount volumes to it because they filled up that root volume. So that root volume is really not intended to contain any files that my users might use. It's just a starting point for the namespace. So it's the kind of place where, like, if I've mounted my clients to the root volume, they're always going to hit the root volume first before they actually navigate to the rest of the volumes that belong to the SVM. So by replicating the root volume and creating it read-only and redirecting all my clients to it, I can have a copy of it on every node and then kind of load balance out access to the root volume. Thus, it's called a load sharing mirror. Okay, so the load sharing mirror is only for NAS purposes. Okay, and in fact, in the NAS world, it's not even supported for NFSv4 at this point. And it's all about creating, again, multiple copies of that particular volume. So I have a source volume, and of course, we replicate to the destinations. So they have to make special connections if they want to modify the source. There's a special syntax that they have to use. But once I set up the load sharing, what everybody is automatically redirected to, if they're mounted, for example, to that root volume, is actually the destinations, which again are read-only.
We've got a quick question here.
Sure.
Flex Clone says it is no overhead on storage, but when split, the clone, will it create separate volume and consume the space?
Yes, and that's actually, I was trying to explain that. So again, when I initially create the clone, it's just like a snapshot. It does not consume, or consumes really negligible space, right? It's just a copy of those pointers. But when I split it, it has to get its own copy of any of the data blocks that it had in common with the original volume. Thus, that's when it's going to actually consume space and be viewed as a separate volume that I can, like, snap mirror as I wish to and move around as I wish to. It's no longer dependent upon that parent and that underlying snapshot. So yes, that is exactly what happens with the flex clones. So they're not only created really quickly so I can get immediate access to them, but when they're initially created, again, they don't consume more space than say the snapshot consumed. As I change it, even if it's a clone, as I start changing the data, as I start working on it, you know, modifying that existing data or deleting data, it will increase in size because it has to keep track of then data blocks that it's only pointing to. So as a clone, it can increase in size, but it will definitely significantly increase in size when I split it from its parent, because it will get, again, the copy of its own data blocks. That is, at that point in time, I actually have to create copies of data blocks. Thus, the split process can also take some time to complete. Okay. All right. So now, SnapVault, SnapMirror. Again, SnapMirror relationship. I am replicating from my primary to what we call a data protection volume, a volume that is of type data protection. Again, it's read-only access. You can't actually mount the volumes if you wanted to. Okay. And we create policies that will determine how often we want to replicate. For SnapVault, we have to specify an additional setting. So SnapVault differs from SnapMirror in the sense that SnapVault is not an exact replica, but it contains more snapshots on the destination. Because SnapVault is all about archiving. So I might have like, you know, 10 hourly snapshots that I create for my source, but on my destination, maybe I want to have 30 hourly. And maybe I'll have like 2 weekly that I create on the source, but I want to have 52 weekly on the destination. So the trick here is, how do I tell the system that I want to retain like more of these snapshots on this destination? And so these SnapVault policies are the key to this, okay? And they are doing it based upon a setting that is called the SnapMirror label. If you were seeing me at this point, you would see me rolling my eyes because it annoys the heck out of me that they call it the SnapMirror label. Isn't that confusing? And in fact, when I first went through, train the trainer kind of training for, and they had first implemented SnapVault, the guys who wrote the curriculum didn't really understand the relationship between SnapVault policies and that SnapMirror label. Because the way they explained it, it didn't make any sense to me. So we had to bring in one of the engineers to actually explain it. So the idea, what they set up, and again, those dang engineers, it's because the underlying hood, it's actually SnapMirror. That's kind of why they're doing it. But we call it SnapVault. So couldn't you have called it SnapVault? At least in the GUI, call it SnapVault. Anyway, so the idea is the snapshots that are created on the source are based upon a snapshot policy. And that snapshot policy has entries in it that say like create hourly snapshots based upon, this schedule, retain 10 of them. And then it's a third column that is the SnapMirror label. So I might call this SV SnapMirror or SM, or sorry, SV hourly. That would make more sense. Hourly. So the idea is when I create this SnapVault policy, I will have multiple entries in it, and it will reference the snapshots that are created on the source based upon their SnapMirror label. So it will say SV hourly, I want to keep 30 of those. And so again, on the source in my snapshot policy, I'll have like another entry saying on the weekly schedule, keep 2 of my snapshots, but for the SnapMirror label, call it SV weekly. Yes, I know my handwriting's horrible. Blame my parents. They were doctors. I'm challenged. Anyway, so over on the destination here in the SnapVault policy, then I would say of SnapVault weekly, I want to keep 52. So the relationship between what's going on the source and what I want to keep on the destination for SnapVault purposes is all around that SnapMirror label. And thus, again, the updates will be made based upon the SnapMirror label. So it's very, very important to understand that piece. Okay. So again, Snapshot Policy has the SnapMirror label built into it. And here we're looking at the Snapshot Policy. So it's these values over here that we're trying to match when we create the SnapVault policies. So basic setup is the same as Snap Mirroring. I got a destination volume. I'm going to create the relationship, and I do an initial baseline transfer. The only real difference for SnapVault is when I create the relationship, I say it's a type XDP. And I'm going to apply that extra policy that specifies how many of those snapshots I want to create. All right, 45 minutes. So that was my goal. Again, purpose here was to really focus in, and of course we can go into more depth on a lot of these things, but focus in on that basic snapshot technology and not only understand how it works on the local systems, but how it is used behind the scenes for my replication, my cloning, my archiving types of solutions like FlexClone, SnapMirror, and SnapVault. So, all right. So I just want to thank everyone. If there are any other questions that have come up.
Not seeing any questions in the question box.
All right. So I want to thank everybody, and please give us any of your feedback, and hopefully we can have some more fun again sometime.
All right. Well, thanks, everyone. Please feel free to reach out to me at dan.murphy@quickstart.com if you have any feedback, questions, or suggestions. I'd love to hear from you. Thanks again for joining the webinar, and have a great day.